Welcome to the DIY Honda Garage channel. DTC P0112 pertains to a fault in the intake air temperature IAT sensor circuit, indicating low voltage conditions. This issue typically arises when the voltage falls below an acceptable threshold of 0.08 volts. The IAT sensor helps the engine control unit, ECU, adjust the air-fuel mixture based on the incoming air temperature, which is crucial for optimal combustion and engine efficiency. The sensor itself is often located near the mass airflow MAF sensor, both working collaboratively to provide the ECU with data on the temperature of the air entering the engine. It is essential to understand that an inadequate reading from the IAT can lead to performance issues, increased emissions, or even engine stalling. Before starting troubleshooting, recording all freeze data and reviewing the general troubleshooting guidelines is critical. The IAT sensor is a vital component responsible for measuring the temperature of the air entering the engine and is typically situated near the mass airflow MAF sensor. Its primary role is to provide the engine control module, ECM, with accurate temperature data, which is essential for adjusting the air-fuel mixture for combustion. A failure in the IAT sensor circuit could lead to lower voltage readings, indicating the need for further inspection or component replacement. Poor performance can occur if the sensor's reading is inaccurate, affecting fuel efficiency and engine responsiveness. The MAF sensor also plays a pivotal role in monitoring airflow, and issues between these two sensors can cause cascading problems in engine performance. Therefore, ensuring they are functioning correctly is crucial for maintaining optimal engine operation. When diagnosing DTC P0112, several possible causes must be considered. First, poor electrical connections at the IAT or MAF sensors can lead to erroneous voltage readings, prompting low voltage errors in the system. Checking these connections for corrosion or looseness is crucial in this scenario. A faulty IAT sensor itself could also be the culprit, as sensors can wear out over time, leading to inaccuracies in readings. Another potential issue involves the wiring harness. Shorted wires or frayed connections between the IAT sensor, MAF sensor, and the powertrain control module, PCM, can result in low voltage conditions. Additionally, environmental factors such as heat or moisture may contribute to these electrical problems. Thus, a comprehensive assessment of all associated components is essential for accurate diagnostics. The symptoms resulting from the P0112 DTC primarily revolve around engine performance. One of the most noticeable effects is poor engine performance, as the vehicle may struggle to accelerate or respond sluggishly to throttle input due to incorrect air-fuel mixture adjustments. Increased fuel consumption can also manifest as the engine attempts to compensate for perceived improper air intake conditions, leading to inefficient operation and elevated emissions. Drivers may also experience the illumination of the check engine light on their dashboard, indicating that the engine management system has detected a fault. Additionally, intermittent stalling or hesitation may occur if the sensor issues are left unaddressed. Recognizing these symptoms early can significantly improve the overall maintenance and longevity of the engine. Step 1 in troubleshooting for DTC P0112 begins with turning the ignition switch to the on position. This action activates the vehicle's electrical systems without starting the engine. The next step involves checking the IAT sensor values using the Honda Diagnostic System, HDS. It is crucial to monitor the voltage levels produced by the IAT sensor and compare these to the specified threshold, which should not be less than 0.08 volts. If the current condition matches the threshold, it indicates that the failure can be replicated, allowing the technician to proceed to the next step. If the readings do not align with expected thresholds, it suggests that there may be intermittent issues within the system, necessitating further inspection of wiring or connection integrity at the MAF sensor, IAT sensor, and the PCM. In step 2 of the troubleshooting process, the technician should first turn the ignition switch to the lock 0 position to ensure that the vehicle's electrical systems are off. This is a safety measure, preventing any unintended electrical shorts or injuries. After the ignition is off, disconnect the MAF IAT sensor 5P connector. This disconnection enables a focused assessment of the IAT sensor. Again, the technician will turn the ignition switch back to the on 2 position. Using the HDS, the next task is to examine the current IAT sensor values once more. If the voltage remains below the threshold of 0.08 volts, this indicates a probable failure of the IAT sensor or MAF sensor, warranting their replacement and further verification of the repair. Step 3 involves diagnosing potential wiring issues associated with the IAT sensor circuit. To begin this step, once again, turn the ignition switch to the lock 0 position. Following that, the technician will jump the SCS service check signal line using the HDS. This is a procedure that allows for diagnostics without interference from active sensor signals. Next, disconnect the PCM connector B, which contains 49 pins, to isolate the circuit for testing. The technician will then check for continuity between the designated test points, specifically between the red wire pin from the MAF sensor/IAT sensor 5P connector and the body ground. This testing condition requires that the MAF/IAT connector and the PCM connector are both disconnected. If continuity exists, it suggests that there is a short in the TA wire, requiring immediate repair. Conversely, if there is no continuity, the wire is intact, leading the technician to consider updating the PCM for the latest software or substituting it with a known good unit. After completing the necessary repairs, executing a final repair verification is crucial to ensure all issues have been resolved effectively. Start by turning the ignition switch to the lock 0 position and meticulously reconnect all previously disconnected connectors. This includes the MAF sensor/IAT sensor and the PCM connectors. Next, turn the ignition switch back to the on 2 position, activating the electrical systems. Now, a crucial step is to reset the PCM using the HDS. This reset will clear any stored trouble codes and allow the module to recalibrate itself based on the repaired components. Additionally, performing the PCM idle learn procedure can help optimize the engine's operation. Finally, check for any pending or confirmed DTCs with the HDS to confirm that the P0112 DTC is no longer indicated. To ensure long-term reliability and prevent issues related to DTC P0112 in the future, a series of preventive maintenance practices are recommended. One of the most effective measures is to regularly inspect electrical connectors for signs of corrosion, damage, or looseness, as these can directly impact sensor performance. Performing software updates on the PCM periodically is also crucial. Manufacturers frequently release updates to improve performance and fix known issues. It is equally important to check for wear and tear on wiring harnesses, as frayed or damaged wires can lead to shorts or disconnects in the sensor circuit. Additionally, maintaining a clean engine environment can help reduce dust and debris that may interfere with sensor readings. This proactive approach can mitigate problems before they arise, contributing to a smoother, more efficient engine experience. In conclusion, DTC P0112 indicates a critical issue regarding low voltage in the IAT sensor circuit. making it essential to address promptly. The IAT sensor is indispensable for accurate air-fuel mixture adjustments, and any malfunction can adversely affect overall engine performance and efficiency. During troubleshooting, it is vital to methodically check the sensor readings, inspect connections, and assess wiring integrity. Properly understanding the relationship between the IAT sensor, MAF sensor, and the PCM allows technicians to pinpoint issues more efficiently. Employing preventive maintenance measures can help avoid recurrence of this issue. Ultimately, ensuring the proper operation of the IAT sensor will contribute to a smoother, more reliable vehicle performance. Please like and subscribe to the channel. See you next time!